Hi everyone. So in this video, we will see Spark has recently introduced custom source. So as part of this use case, we'll try to understand custom data source and we'll create our own data source for reading YAML files. Since we don't have existing methods to load YAML data directly, we will create a custom YAML data source and we will also do the validation of the schema. So let us start with the basic, right? So first step, right, we will basically do the necessary imports, and once the imports are made, we will import this helper notebook. So I'll come to this helper. So this is necessary for the validation of the schema. So and then we will have the validation for our given schema. So we are planning to load a YAML file. Let me show you the YAML file. So, so since Spark is basically doesn't have, I don't have any cloud, so I'm having a local couple of YAML files, and I will load it to a executor path so that it is available for executor to read from the executor. Since unlike your normal data load where it will, if you're using pure python to load yaml using pyyaml, it will load from the driver. So it will kind of a single node task. So now we will leverage this custom data source and load YAML parallelly with our executor part, right? So since I don't have any cloud or any Azure file system, I'm having a local copy of YAML data, so which I will basically copy to a local path, and then I will add it to the executor directory. So this is the directory in executor where it is the files will be available. So the spark add file will basically allow you to add any custom file from your driver to the executor. And since we are loading a directory, we are adding the recursive true, as you can see here, right? Add file has two parameters, path and then the recursive true for loading a directory, right? So let us little bit see the YAML data before we load understand the custom source. So let me quickly do a cat of one of the files. So in order to explain easily, I have taken the DMT YAML files so that it will be more realistic, right? And we will see how to do the validation of DBT YAML using PySpark. So as you know, right, DBT YAML will have a version, and then they will have models corresponding to the table name, and then the columns name, and the description of the columns, and there will be some comments as well. And if there are any tests, the test cases will also be available, right? So now let us try to validate the schema, right? So for validating this YAML, right, and to load the data through Spark, so we will use the custom data source. So the custom data source source code is basically here. So the data source, right, as you can see here, it has a init method, and we have a name. So this will be when you give spark.read.format, right? When you give CSV, right, it is loading, right? So that name will be given through this, and then we have a schema. So this is the schema, right, against which the data will be validated. And then we have a reader. So this reader is the main piece. So this needs a reader class. So let us see the data source reader class, right? So the data source reader class has two methods, right? So one, it has a partition. So you can assume like a partition is something like if you have a single partition, all the data will be loaded like a single driver, right? Similar to what you do in your driver node, right? And if you, the more the number of partitions you have, the more the parallelism you will keep. So this will be a array field. So if you see here, right, it should return a array field. So for example, in this case, we have three partitions, right? Input partition 1, 2, and 3. And based on this value, what we are passing, right? So in this case, we are passing a value of 1, right? So like this, we can pass our own value, and we can use that for our parallelization, which I will show in the demo, right? And then we have the read method. So since here we are only focusing on reading the data and how to do the validation of the YAML data, right, parallelly, right? So this, as you see, right, this read method will be called for each of the partition which you define parallelly. So that means the more the number of partitions array you create in the top, the more it will be, right? So these are the key methods. Now let us see how we can define it for our YAML source, right? So I am inheriting the data source reader. So this data source reader needs to have two methods. So one is a input partition. So I just keep a single partition for now, and we need uh, the bucket. I mean, these are internal methods, so I will come to it later. And we have the read method, right? So the read method, right, will take, so in this case, right, the code is written in such a way, right, through this partition whatever we are passing. So each partition will be having a list of files. So what we are doing here is, if you see here, right, for each files in the given directory, we will basically try to get the hash value and then divide it into the number of buckets. So for example, if we have three partitions, all the data belonging to partition 0 will be read parallelly. Similarly, partition 1 will be read and partition 2 will be read. So for parallelizing the reads, we are using this logic. So this is like which is a common bucketing or hash based partitioning, right, which will be there in the traditional Spark. So we are using this method. So what we are going to do now is, we have the, so we have our source defined, right? And we have the read method. So in this read method, we are reading each of the file, and for each of the file, right, we are giving a PySpark to schema to Pydantic schema, right? So what this means, right? So let me show you what this Pydantic means, right? So this is especially useful uh, in case of you have a validation to be performed, right? Say in this case, we are trying to fit our YAML to a specific schema, right? So in Python, if you want to do similar thing, you have something known as Pydantic. Say for example, here I have a user, and it should have values like ID, name, email, age, and hobbies, right? So if you see here, right, I am creating a dictionary. So YAML, when you read, right, again it will be dictionary, right? So what it will do is, see, it will go and fetch out of this all the fields, right? See, this other field is an unnecessary field. So it will try to fit the schema, and then it will load the data. And when you pass a invalid data, right, so it will throw a validation error. So this will be the key principle, right? So what we are trying to do here is, we have a PySpark schema, right? So from the PySpark schema, we will convert it into the YAML based schema, right? Or your Pydantic schema. So this is the schema we are having, right? So before we go to the data, so I showed the data. So for the data we saw, right? So we have a version field, and we have a models, and then we have a corrupt. So this corrupt is similar to our corrupt record in normal reads, right? So if you have a corrupt record which is not fitting the schema, the entire content will be loaded in this corrupt field, right? And the model schema, we will have fields like column, names, and then description. And we have the, again for models we'll have a column, and column again will have a schema, like it will have the description of the column, the name of the column, and test, right? This will be again an array field. So it is like we are trying to fit the YAML schema and extract the necessary fields from the given YAML, right? So the default implementation, if you see here, right, it forces you to basically give a schema, right? If you see the default implementation of data source, right? Yeah, if you see the default implementation of data source, so basically, they are asking you to provide the schema hard coded, right, like this, right? So, but it doesn't allow you to validate, right? So we need to tie up the given schema and the YAML which we read in the Pythonic way, right? So for that, what we are doing is we are basically leveraging this PySpark schema to Pydantic. So in this PySpark schema to Pydantic, we are doing nothing but we will basically read all the fields in the given schema, and we will do a mapping. Say for example, right, if the type is integer, then load it as a int type in Python, and like that. And if it is an array field, then we have to create a list of basic fields. And if it is a struct, then we need to basically do a nested model, right? So this will be nothing but a child schema which we are creating, right? So on high level, we are trying to map the Python schema or your PySpark schema to a normal Pydantic schema, so that what we are trying to do is we are ensuring that we are not just loading the YAML data, but we are also verifying the schema, right? So now this is the first step. So we have like created both the classes. So one is your data source reader, so that will have the read method on how it should process. So here we are processing by reading all the data in a given folder, and that folder is parallelized through the given number of partitions. So for the first step, right, we are basically giving a single partition, and we are registering the source. So the data source class will call this YAML config reader, and the name we are giving it as YAML, and the schema we are giving it as the dbt schema, right? So let us give this one. And the next step is we have to register the schema. uh, sorry, register the source. So this YAML reader, right, it is defined here, right? So we are defining the YAML reader, and we know. So once you register it, so this is the path where we have loaded our files. So when we load it, we are reading the data, right, and then we are doing the display. Okay, now if you see here, it has passed the data for both the valid YAMLs, and the sample is a corrupt record where I have just sampled the value, right? So if I show you quickly the sample file, right? So sample is nothing, the corrupt file, right, which is nothing but it will just have a corrupted YAML. It's not a YAML, it's just having a text. So as we expect, right, we are able to read the data using YAML format, right? But one or couple of challenges here, right? One is, if you watch carefully, we are hard coding the schema here, right? So this schema is getting hard coded. So that means you have to create one class per schema, right, which is not good. So that is where we are going with the next option. And the second thing is, we have given only one partition, right? So you will see get partitions, right? So that will give only one. So why? Because this property, right, on how it is parallelized while reading, it depends on the input partition which you create in the reader. So in this reader, if you see this partition method, we are just defining only single partition, right? So as a next step, what we will do is we will basically extend this simple code, and we will make dynamic schema handling and then parallelism, right? So what we will do now is, okay, now we will see how we can read the schema parallelly, right? So we are taking the same reader class which we had above, and we basically have a couple of limitations, right? One is the schema, whatever you pass here, it should be either a string type or it should be something which you get from the options. So, but unfortunately, the options type, right, it can accept only string. So even if I pass a direct struct type of schema, it is not working. So that is where we have come up with this hack. So what we will do is we will get the original struct type schema, convert it to a JSON representation, and pass the JSON representation, and we are dynamically constructing the PySpark. We are using the JSON schema to Spark. So the JSON schema to Spark, right? So this will basically iterate your given set of fields, and it will convert to a JSON to a PySpark array or struct type, right? The corresponding schema, right? So if you see here, right, we are basically converting this to a corresponding individual type. So if it is string, you convert it to a string type, and if it is an array, just convert it to a array of type, right? We need to solve two challenges. Number one, we have to basically pass the schema dynamically, and number two, we also have to pass the partition dynamically. So what we are doing is, first we will see the schema. So for passing schema, either you can hard code like in the previous step, or we have to pass dynamically. So how you can pass dynamically is through only the options. So I'm getting one more parameter YAML schema, which will be passed through as an option, and there we have to basically pass a JSON representation of Spark schema. So which is nothing but the thing which is given here. The reason is simple, because the options dictionary, right, it is converting everything to a dict of string. Even though we have defined at any type, it is converting by default as a string. So since both the struct type schema, whatever we have created earlier, if it is converted to a pure string, right, then it will not be able to pass to a Pydantic version. So what we are doing is we are converting it to a JSON based schema, and we have a helper method which will iterate the fields. So this JSON schema to Spark, right? So it will take a dictionary which will iterate each of the field. And what we are doing is, since we are using mostly string and array type based on the instance of the JSON, right, like field, the type of field here, we are creating the field, right? So for example, right, see, first it will check the type. So if the type is string, then here directly will create a string type for that field, right? And if it is not a string, say an array field, then it will create an array type element. So we are dynamically creating or converting a JSON schema to the Spark representation, right? Now the schema thing is fixed. The next step is we also need to ensure that we are reading parallelly. So what we are doing here is we are basically having the num partitions, and we are iterating here. So for each of the partitions, right, it will try to read its own set of data, and then finally it will load, right? So now let us register this YAML source reader 2, right? And we will basically create the JSON representation using dbt schema. And now if you see, right, we are passing a couple of other options. So we are passing the schema, and we are also passing the partitions as 3, right? So now if you read the data and if you display the data, right, so we will still get the same, right? But one thing which you could observe now is, right, it would already has multiple partitions, right? It is not, see, there are 2 partitions has been created. The same has been verified using, we can also verify using get num partitions. So yeah, so pretty much that's all I have for this video, right? So in this video, we'll learn how to define a custom schema and how to dynamically change the custom schema partitions, right? So that we can leverage the full parallelism of Spark, right? Yeah, that's all I had. Thanks everyone. Please do like and share.